Alright, so going off of yesterday's lesson about Le Chatelier's principle, we're now going to apply this to an example, and we're going to try to predict the shift. And as a reminder, the shift should always be the opposite of the stress. So let's take a look at this first equation. So I have an equation here where CO and Cl2 are reacting to form CoCl2, and then there's this backward reactions that goes backwards. And so we have one side that goes forward, and then we have the backward reaction. The question says it's already at equilibrium, meaning that they are going the same speed, so we shouldn't see any changes over time. Now, just because it's in perfect balance doesn't mean it's going to stay that way. So we're going to apply a stress. This is the stress. Okay? So, oops, you didn't see that. So what does it mean that this is a stress? Well, this means that while it's perfectly balanced, we're going to kind of mess up this balance by removing some CoCl2. It is now no longer in balance. So the system is going to try to shift in a way that makes this imbalance less painful. It basically wants to do the opposite of the stress. So I need to shift in a direction that makes this the opposite. What is the opposite of removing CoCl2? The opposite is to add CoCl2. The question is, which direction will favor an increase in CoCl2? Do we want to shift in the forward or the right direction, or do we want to shift in the left or reverse direction? Which one will accomplish the opposite? I want to shift to the right. When I shift to the right, what will happen is the right side will increase and the left side will decrease because it gets used up in order to make the product. So we'll say this shifts to the right. You can say shift right, or you can even say forward. They mean the same thing. Okay, let's do a second example. And it is to add chlorine gas. To be clear, chlorine gas happens to be this thing here. Okay? So this is a stress. We're going to add the chlorine gas. Figure out which direction of shift will do the opposite to the stress. Talk with your partner. Now, go. All right, so what is the opposite of adding chlorine gas?
Removing chlorine gas.
It is to remove chlorine gas. And so I want to move in the direction that removes chlorine gas. The direction that removes chlorine gas is to the right. Let's talk about why this. When I shift things to the right, we're going to use the things on the left to make the things on the right. By shifting to the right, I should have less CO and less Cl2 and more CoCl2. You'll notice that most people picked left because the last question was right. So I made it a point to make 2 rights in a row to see if you really knew what you were doing. I'll take some questions. All right, let's try another example, shall we? Okay, here's our second example. In this example, there is a few other things in play here, and so we'll talk a little bit about what's happening here. So again, these are stresses. The system is already at equilibrium, and we're going to apply this stress to it, which should then mess up the equilibrium. I'd like you to think about what is the opposite to this stress, and which direction will accomplish the opposite to the stress to try to restore balance, a new equilibrium.
Right.
Okay, So the opposite in this case is to add O2. And I want to move in the direction that points towards the O2 so that I can increase the amount of O2. And shifting to the left is where the O2 is located. Left is the correct answer. Shifting to the left. How was that? Yeah, we're getting better at this, right?
Yeah, I'm so confused.
Okay, let's try another example. And here is your next example. All right, so my next one is actually very similar to the one we've done before. This one happens to PBS. Yeah, PBS kids. Okay. This time around, instead of writing the opposite and writing a direction of shift, I just want you to verbally talk with your partner and come up with some answer. See if the answer is not to the right. The answer here is no change. Write it down. It turns out that solids, but not just solids, solids and liquids go through a no change system. The reason for this is somewhat complicated, but it's because the concentration of solids and liquids don't actually change. Even though you might have more solid or less solid, the actual concentration, moles per liter, is actually still the same, mainly because the density doesn't change. And so anytime you see a solid or liquid, and it will be denoted in the actual equation, and you see an S or an L, automatically the answer is going to be no change. I'll take some questions. All right, next. Let's try one last one. We did that one. Okay. So I'd like you to draw both of these graphs. And you'll notice the one on the left looks a lot like the one on the right, except they're kind of like mirror images of themselves, like your two hands. Your two hands are mirrors of each other. Now, the one on the left has kind of a higher starting point than its ending point. It actually starts in this like top section and it ends a little bit lower. We actually have a name for this thing, and we call these things exothermic. The reason why it's called exothermic is because this heat energy is being lost. We're starting at a higher position, we're ending at a lower position. The delta H for these type of reactions are negative, but what we want to do is actually put it into our equation. And so we can think of this as a kind of product. So exothermic reactions not only produce products, they also produce leftover heat energy. And so I want you to think of them like it was a product. So what does that mean then? Well, it means I want you to treat it like it was an actual product. So if I have a reaction, A goes to B, you can think of this energy as kind of like a product, or it goes on the right side of the equation. Now, if we compare this to the one on the right then is not exothermic, it is endothermic. And so on this other side, we can say that this side is endothermic. What can you tell me about the delta H for endothermic reactions?
It's going to be a positive number.
Delta H is going to be a positive number. And we can think of the heat on this side as a reactant. What does that mean? Well, if C is going to D, we can think of the energy as being on the left side. Meaning that in order to turn C into D, I actually have to gain some energy. The best way I can kind of describe this is one is worth more than the other. Okay? So if you go from a higher worth to a lower worth, then you basically have to, there's some extra cash left over, extra energy left over. If you go from something that's lower worth to higher worth, then you have to add cash. Okay? This happens a lot with like Craigslist transitions. So if you have, say, a trade. So let's say I had an iPhone X. And I wanted to trade with someone who had an iPhone 8. Which one's worth more? The 10. And so when we apply this trade, I should get the 8 plus something else. Cash, typically. Okay? So I'd get the iPhone 8 plus $100 or something like that. Now, if it's the other way around, and I had an iPhone 8 and I was trading for an iPhone X, what I would do then is I would then add cash to my iPhone 8. Does that make sense? This is essentially what's happening. When you go from a higher heat energy to a lower heat energy, you go from a 10 to an 8, you get some cash back along with it. So if you look on this product side, it's A goes to B plus energy, plus that extra cash. But if C has a lower cost or worth than D on this right side over here, then when you go from C to D, you have to add cash in order to make that transaction happen. Does that make sense?
Endothermic has the iPhone 8.
Endothermic means you're going higher or up the scale. Cool? Okay. What does this have to do with anything? Well, it turns out that we can actually apply this to Le Chatelier's principle. And so on this example, we're going to do something new and something slightly different. Let's take a look at this example. So the first question I have for you then is this example an exothermic reaction or an endothermic reaction going in the forward direction? And how do we know this is an exothermic reaction? Yes, it is a delta. Oops, it's not working here. We know it's exo because the delta H happens to be a negative value. Because it's a negative value, it tells me that we're losing energy. We're going from a higher state to a lower state. We're going from the iPhone X to the iPhone 8. Okay, now, if this is an exothermic reaction, should my energy be on the reactant side, the left side, or should be on the product side? Am I going to add cash energy into this equation, or am I going to get cash energy back? We should get cash back. We should consider this a product. Any questions about this? Where should I write the energy on this equation? Should I write it on the left side, or should I write it on the right side? Which side? I'm going to write it on the right side. I'm going to write this down as heat, or you can write it down as energy. Sometimes people actually write the amount of energy, like 35 joules or 360 calories. It'll never show up as a negative value. The negative just tells me it shows up on the right side. If it were positive, that actual value, these calories or joules, will then just show up on the left side. You don't give someone negative cash, right?
You give them debt.
Yeah, it is doable, but never in a Craigslist transaction, right? You don't trade with like, I'm going to give you my phone and some debt, right? It just doesn't work out that way, right? If that were the case, walk away from that like transaction. Okay, so what does this have to do with stress? What we're going to do is we're going to apply a stress to the system. So I want you to imagine that this is in perfect equilibrium, meaning that the forward direction is in balance with the reverse direction. So what is the opposite of removing heat? If this is the stress, the opposite should be, let's try that again. The opposite should be adding heat. And which direction will add heat? Shifting to the right or shifting to the left?
Right.
Shifting to the right. Heat's located on the right side of the equation. We're going to say this shifts to the right or in the forward direction.